All right, welcome everybody. So we have discussed what the Gram-Schmidt process is. So recall that that is a process for taking a basis for a subspace W and being able to find an orthogonal basis for that same subspace. And again, these orthogonal bases are particularly nice to work with when we want to find projections of vectors into subspaces. So in this case, we are going to start with a subspace W, which is a subspace of R4, which is spanned by the following two vectors in R4. The first basis vector is the column vector 1, minus 4, 0, 1. And the second column vector in this basis is 7, minus 4, and 1. So these two vectors initially are not orthogonal to each other. So how can I generate a basis for this same subspace, which consists of two vectors that are orthogonal to each other? And so let's recall the Gram-Schmidt process that we have for generating such an orthogonal basis. So the first vector that we pick, v1, we just set equal to the first vector in the initial basis that we have. So in this case, v1, I set equal to x1, which was the column vector 1, minus 4, 0, 1. So then to find v2, we find the orthogonal projection of our next vector x2 into or onto the subspace spanned by v1. And then I'm going to subtract this vector from x2. So the resulting vector v2 is going to be the complement of the orthogonal projection. So I'm going to get a vector v2, which is orthogonal to the first vector v1. And then we would continue this on, but for our case here, we just have two vectors. So then to find the next vector in our basis, we go ahead and take x2 minus x2 inner product with v1 divided by v1 inner product with v1, and we multiply that by the vector v1. And I will skip doing the calculations here, but you can verify these calculations in the Google Colab notebook using Python, which is linked in the description of this video. So x2 was the vector 7, minus 4, 1. Calculating the inner product of x2 and v1, that gives us 36. The inner product of v1 with itself, that gives us 18. So from x2, I'm going to subtract 36 over 18, 2, times our first basis vector, which was 1, minus 4, 0, 1. And so here the arithmetic is pretty nice. I would get 7 minus 2, which is 5, minus 7 plus 8, which gives us 1, minus 4, minus 0 is minus 4, and then I get 1, minus 2, which gives us minus 1. So v2 is going to equal the column vector 5, 1, minus 4, minus 1, and you can check that v2 is orthogonal to v1. When I take the inner product of v2 and v1, we get 0. So this gives us a basis for this subspace W, which is an orthogonal basis. So the first vector, again, would be the column vector 1, minus 4, 0, 1. And the second basis element is 5, 1, minus 4, minus 1. And these two vectors are now orthogonal to each other and span the same subspace as the original two vectors that we started with. And this algorithm that we're applying here, this process for generating this orthogonal basis, again, is what we call the Gram-Schmidt process. So here we've done it for a subspace which is spanned by two vectors. I will do a video with an example where we have more than two vectors if you want to take this process out to further steps.